process flow diagram above shows the production of isopropyl alcohol through the hydration of propylene. First, the propylene is fed into P1 feed pump and water is fed into another feed pump labeled as P2. The function of the pump is to transport fluids from one unit to another unit. P1 is connected to H1, which is the heat exchanger, which is used to heat up or cool down the stream. In the PFD above, the heat exchanger acts as a cooler to cool down the inlet stream, which is the propylene feed. Next, the water and propylene are fed into the reactive unit C1 where the raw materials or reactants react and produce products. In PFD, the reactants are water and propylene while the product is isopropyl alcohol. Next, before calculating mass balance and energy balance for reactive unit, we must make some assumption. Only 85% of propylene is reacted with water. Molecular weight of propylene, water, and isopropyl alcohol are 42, 18, 60 kg per kmol respectively. 60% of the output of water will feed into the bottom stream of output.
For energy balance, the first step is we need to sketch a labor flowchart to show exactly the process that happened. Then we need to do the energy balance equation. And the second step is we need to prepare inlet-outlet enthalpy table for expressing the molar flow rate and the specific enthalpy for each stream. The third step is we need to perform mass balance, and after that we need to determine the reference state for each component for inlet and outlet stream. Then we need to find the enthalpy for each component based on their change. For example, if the component have change in temperature, we need to do the integration based on table V2. For pressure change, we need to use formula V delta P, and if they have change in phase, we need to add heat of melting or heat of vaporization. Lastly, we can finally find the delta H and solve for the energy balance.
For absorption column or non-reactive unit, we also make some assumptions as follows. Take the absorption efficiency is 92%, molecular weight of ethylene glycol, water, isopropanol are 62, 18 and 60 kg per kilomole respectively. They have two inlet streams, which is L1 and G1, and two outlet streams L2 and G2. L1 is from the bottom product of C1 reactor, which consists of isopropanol and water, while G1 consists only ethylene glycol, which is used to absorb water from isopropanol. The inlet molar flow rate of isopropanol, water, and ethylene glycol are 171.2 kmol per hour, 76.88 kmol per hour, and 300 kmol per hour. After the absorption, the isopropanol and a little water will go to G2, while ethylene glycol and water will go to L2. We know that the molar flow rate of ethylene glycol and isopropanol will remain at the same in their outlet streams. The outlet molar flow rate of isopropanol and water in G2 are 171.2 kmol per hour and 6.15 kmol per hour, while the water and ethylene glycol in L2 are 70.73 kmol per hour and 300 kmol per hour.
With the knowledge of fluid mechanics, we were able to design a pipeline system that can be used to transport the fluid from one unit operation to the other unit operation efficiently. In this pipeline system, we divided the pipeline into 8 separate pipes where the fluid flowing through each pipe is different. The characteristic of each pipe may vary due to the type of fluid flowing, the velocity of fluid in each pipe, and the needs of fittings across the pipeline to elevate or control the flow. There are a variety of pipe size used to ensure the velocity of the fluid doesn't exceed the acceptable range and prevent excessive pressure drop across the pipeline. For example, there are two types of pipe used in this pipeline system, which is polyvinyl chloride pipe to transport water because it is cheaper, less friction and doesn't corrode, while for other fluids such as propylene, mixture of propylene and water, isopropanol and ethylene glycol, stainless steel pipe is used to transport those fluids because they doesn't react with stainless steel, and stainless steel pipe also can withstand high pressure. For the fittings, 90-degree long radius elbow is used because it has less friction since it is longer and have gentler turn. Other than that, check valve is installed after the pump to avoid reverse flow which can affect the efficiency of the pump. Lastly, globe valve is also installed after the pump to regulate the flow before entering other unit operations. In order to calculate the pressure drop, we made a few assumptions, which is steady flow, which means mass flow rate in equal to out, incompressible fluid indicating no density change due to pressure and temperature, the velocity change is 0 since the pressure drop is measured in the same pipe, the power of water pump is 750 watts and the power of propane pump is 400 kilowatt. In this calculation, the first step is to find the velocity using the volumetric flow rate. Then the Reynolds number is calculated to find the characteristic of the fluid. After that, we will calculate the friction factor and the friction loss due to length, fitting, sudden enlargement, and sudden contraction. Then, work done by pump is also calculated if there's a pump along the pipe. Lastly, the pressure drop is calculated through Bernoulli equation that relates to the conservation of energy. Here is the full step of the calculation. And this is the summary of pressure drop across all pipelines.
Main product delivery strategy. Isopropyl alcohol, or also known as isopropanol, is the main product of this process, which will be transported to the storage tank. There are a lot of things to be considered, such as: first, the piping system. A stainless steel pipe will be used to transport isopropanol because it has high resistance to corrosion and durable. It also can reduce the rate of corrosion that can affect the flow of isopropanol. Second, the cooler. A cooler is used to convert isopropanol vapor phase into liquid phase. If vapor flows through the pump, it can cause corrosion and affect the pump efficiency. Isopropanol that is stored in liquid phase is safer because it can reduce the risk of accidental ignition at the production plant. Third, the centrifugal pump. A pump is needed in the piping system to transport the isopropanol into storage tank. The inlet of the storage tank will be on top to prevent spills and overflows of isopropanols. Thus, a pump is required to increase the pressure inside the pump that helps isopropanol to flow against the gravity into the storage tank. Lastly, the fittings. The check valve and drop valve will be installed after the pump in the piping system to protect the pump from operating adversely. Check valve is important to prevent backflow when the pump is not in operation. In addition, the globe valve is needed to control the flow rate and the pressure of the pump isopropanol. It helps to maintain an optimal operating condition for the pump and prevents damage to the other unit operation. This is the full layout of the delivery strategy. Before doing the calculation, we need to do some assumption. First, efficiency of cooler is 100%. Second, efficiency of pump is 90%. Third, pressure 1 equals to pressure 2 at the end of the pump operation. And this is the full step calculation. The dimension and capacity of storage tank. First, assuming that the isopropanol and liquid phase will be stored in the storage tanks for 2 days and maximum operation of isopropanol production is only 10 hours per day. The isopropanol stored in the tank would be 262,872 liters. The suitable capacity of storage tank will be 300,000 liters, which is slightly bigger than the volume of isopropanol to prevent overflow of the fluid. The shape of the storage tank is cylinder and the height would be 10 meter and the diameter would be 8 meter. The material of the storage tank would be high density polyethylene because it has high durability. There will be pressure relief valve on the storage tank. The function of a pressure relief valve is to prevent excessive pressure build-up in the tank. Leak detection system is also installed on the storage tank to identify and alert the operators of leaking in the tank.